Subcooling in heating and air conditioning terms, and how to measure subcooling in HVAC terminology. So the simple way, the older gauges may be somewhat analog gauges, so one may need to learn how to calculate these formulas themselves. So, and then question, which side is superheat, which side is subcooling? One may hear these terms in the heating and air conditioning industry, and what do the terms convey to the layman who's trying to reduce the arcane terminology to the lowest common denominator in a make sense kind of way? Simply, the superheat is here when one has a split unit, meaning say the condenser may be located outside, the air handler inside, and one may see two copper lines, a larger copper line and a smaller copper line. The larger copper line often has insulation located on it, and so this would be for your A coil. Now this would be for normally the inside unit. If it's a package unit, it could be outside because everything is one big box, but this would be where one would measure superheat. So where would this would leave you? You have two terms, superheat and subcooling. So subcooling would be measured on the high pressure side. The low pressure side may be the blue side, the high pressure. So they kind of put it, it's kind of like a, you just think of the red as kind of being kind of high pressure, hot, the blue being low pressure and cold. So what one does is actually hooks you have to have a thermostat thing, I mean not a thermostat, but a connection which will measure the temperature from the line set, which would be the smaller, should be the smaller line on the out of the two lines. Say you had a larger line and a bigger line. The larger line would be the suction line. The smaller line would be the liquid line or the high pressure line. So this would be for the smaller or the high pressure line. So if we take the temperature, say hypothetically, if this were the pipe, this is not the pipe, this is just a piece of PEX plumbing pipe. Better yet, if we take red, that would indicate better. Say if we had a temperature thing clamped onto here and we pulled the temperature. Okay, we have our gauges here, and then see our gauges on the outer little clock thing. This would be PSIG. So if it's 100 to 200 PSIG, this would be the PSIG. So if we take the temperature, okay, we get say the temperature here, and then we cross-reference to whatever kind of refrigerant. Say one is using R22 or one is using 410A. So basically, if you take this and say if we're at a 200 degrees, we're close to 100 degrees if we're using R22. So let's just say 200. Use this number, cross-reference this to this number here to the degrees, and then we flip this gauge upside down, and there's put a little schematic. So subcooling, SC subcooling is an acronym here, equals the gauge which we just figured here would be 100 minus the line temperature. So say hypothetically, if the line temperature was 70 degrees and the gauge temperature was 100, we would take 100 minus 70. This would give us 30 degrees subcooling. So for instance, let's go back over here and say the temperature, say at 100, say if it were 200, 250, it would be somewhere, say, let's just, well, let's just go back, say it's 75, it would be around the 80 mark. So we would say, we would take 80, say the line temperature was, say the line temperature was, say 70 degrees. So we take 80 minus 70, and this would give 10 degrees subcooling. I'm sorry, not superheat. Let me rephrase that. Let me correct myself. So somewhere around the 10 degree subcooling. Sorry about that. It gets sometimes when you get used to talking about both, you kind of get them interchanged. But on the subcooling, so basically 10 degrees of somewhere 10 to 12 degrees of subcooling may be an optimum subcooling temperature. So the formula is just simply subcooling equals the gauge minus the line temperature. So, and now do keep in mind, if you have a digital gauge, if your digital gauges are calibrated correctly, this will actually, it should computate itself, and it makes it a lot easier. But it's good, especially for the newbies in the industry, to know how this is done, what it's done, and there's pressure, temperatures, etc., and there are certain factors. But if you kind of understand the holistic approach to it, you start to understand that the system, how the system works. So when it computates it itself. But if you find you have somewhere about a 10 to 12 degree subcooling, that may be a good subcooling number. So again, but this is from the, again, let's just rehash the formula. Subcooling equals gauge minus line temperature. Gauge minus line temperature. And the optimum would be somewhere around 10 to 12 degrees, but that's not always the case. But these are just digital gauges, so one would hook up their gauge, and then once the gauge is connected, you take the pressure from the outside, cross-reference it. Then once cross-referenced, then you take the gauge minus the line temperature, and one would have to have a temperature clamped onto the temperature, or some way to detect the temperature of the smaller line. And again, this would be the smaller line. So effectively what happens is the refrigerant comes back, comes out of the A coil, comes back to the condenser, and is through the compressor, maybe as a low pressure vapor, gets compressed, then it turns into a high pressure vapor. Once it turns into a high pressure vapor, then the air via the fan usually, now there are other kind of situations sometimes where they bury the pipes and do it that way, but maybe geothermal or something, but most of it's just air cooled. So once the air comes across, then the refrigerant goes back to liquid. So that means sub, so subcooling. So that when you go from a high pressure vapor, and then it comes, then the air comes across, it cools it, it goes back to a liquid, then it goes back to a TXV or a metering device, and then starts to flash in the A coil. But simply the formula to calculate subcooling may be subcooling equals gauge minus line temperature. Again, subcooling equals gauge minus line temperature. Thank you for watching.